welcome back. And now we are in the second topic under chapter 2, histograms. So, part 1, basic concepts of histograms. Key concept: while a frequency distribution is a useful tool for summarizing data and investigating the distribution of data, an even better tool is a histogram, which is a graph that is easier to interpret than a table of numbers. So most of us are visual. Tapos, meron kasing mga tao na sobrang nagiging anxious kaagad pag nakakita ng numbers. So, for some of those people who have problems with numbers, mas magandang gamitin or mas magandang i-present ang data sa kanila by the use of histogram. So a histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there are gaps in the data. So the horizontal scale represents classes of quantitative data values, and the vertical scale represents frequencies. The heights of the bars correspond to the frequency values. So magkakadikit sila. Dinodrawing mo sila na magkakadikit unless meron kang gaps or meron kang mga classes na walang laman. Okay? So, important uses of a histogram. Visually displays the shape of the distribution of the data. Kung meron kang histogram, since bar siya, makikita mo kaagad kung magsasatisfy ba siya. For example, ganito yung itsura nung dataset mo. Parang makikita mo kaagad kung normal ba yung distribution mo or not. Okay? So, kung symmetric siyang ganyan, and then nasa middle yung pinakang peak, then we can assume that our distribution is normal. And also, kung meron kang bar graph, histogram na ganyan, papababa siya, or hindi siya symmetric, then you can assume something about your data values without looking at the raw numbers or raw data. So, makikita mo kaagad kung ano yung behavior nung numbers mo or nung values mo. Next, shows the location of the center of the data. So, papakita niya sa'yo kung nasaan yung gitna. And also, shows the spread of the data. This is something to do with the height. Tingnan mo yung yung height ng mga bars mo. Makikita mo kung mag, halos magkakasing height yung mga bars, hindi masyadong nag-differ yung height sa isa't isa, although papababa. Then, the spread of the data or the dispersion of the data ay maliit. Maliit yung variation or pagkakaiba ng mga values sa isa't isa. And also, ma-identify mo rin yung outlier. Baka may nag-exist dun sa mataas, dun sa, um, may isang nag-exist dun sa right tail o kaya may isang nag-exist dun sa left tail. So, ma-identify mo kung may nag-exist ba na outlier or wala. So, a histogram is basically a graph of frequency distribution. For example, meron tayong figure dito. It is generated using the software Minitab. Medyo luma na yan eh. So, class frequencies should be used for the vertical scale, and that scale should be labeled as in figure 2-2. Ayan. So, tingnan muna natin yung ating table of values at saka tingnan natin yung ating table, ating figure. Ito na naman tayo. Hirap magtaas. Nasaan ang table 2-2? Ito yung kanina. Nasa taas. Balikan lang natin siya, ha? Saglit. Or baka na-paste ko na siya dito. Paste ko ba siya dito? Okay, so this is our table for McDonald's lunch drive-through service times. Ayan. So, pakitandaan, we have 75 to 124 is 11, 125 to 174 is 24, 175 to 224 is 10, 225 to 274 is 3, and 275 to 324 is 2. So, what will the relative frequency histogram look like? So a relative frequency histogram has the same shape and horizontal scale as the histogram, but the vertical scale uses relative frequencies. And then dun sa frequency histogram naman, syempre ang gagamitin natin ay yung mga actual values that we have. So yun lang naman yung kaibahan ng frequency histogram at saka ng relative frequency histogram. Pag frequency histogram, yung actual values, uh, 0, 5, 10, yan, approximately. So for 75 to 124, we have 11, di ba? So just a bit over 10. So ganun yung height ng ating bar. And then from 125 to 174, it is 24, so a little below 25. So i-approximate natin yung height ng ating bars. And for percentages, for the relative frequency distribution, na-compute na rin natin to earlier. So, this corresponds to the first, I think that is 22%, if I am not mistaken. So, 22%, it is a little over 20%. Okay? And then I think this is 48%. Kung tama yung pagkakaalala ko dun sa kaninang mga tables na ginamit natin. Hindi ko na siya babalikan. Pwede nyo namang i-scroll up or down yung module na presented sa inyo or yung book na gamit natin. Okay. So, meron tayong iba't ibang types ng histogram. Kasi for the horizontal line, wala namang sinabi kung ano talaga yung kailangan yung ilagay. So, pwedeng yung boundaries nyo, yung mga class boundaries nyo, yung maging coordinates ng bawat endpoints ng inyong bar. Ayan. Katulad nito, 74.5. Ito yung class boundary natin for the first class. Ayan, 74.5 at saka 124.5. This is the lower class boundary. This is the upper class boundary. Pwede rin naman na kung gusto nyo lesser yung isusulat, pwede rin naman yung midpoint. Dito nyo siya isusulat sa gitna. So, the midpoint of this one is, I totally forgot. I think this is 99.5. Compute natin siya ulit. 75 plus 124. Yun yung nasa unahan natin eh. 199 divided by 2. Yun, 99.5. Pwede rin naman ilagay nyo dito, 99.5 dito sa gitna. Wala naman tayong rule talaga na nagsasabi kung ano yung dapat ilalagay nyo dito sa horizontal line. You can choose between, ito siya, class midpoints, pwede rin namang class limits, o kaya class boundaries. Ayan. Kayong bahala. As long as proper yung representation nyo sa height ng bawat bars and properly labeled yung mga axis natin, okay lang yun. Tatanggapin natin yun. So, critical thinking, interpreting histograms. Even though creating histograms is more fun than human beings should be allowed to have, the ultimate objective is to understand characteristics of the data. Explore the data by analyzing the histogram to see what can be learned about CVDOT or CV-dot. The center of the data, the variation, which will be discussed at length in section 3-2. So, sa, ano pa tayo? Sa chapter 3 pa. Ay, hindi pala. Chapter 2, section 3-2. Ayan. Malapit na rin pala. The shape of the distribution, whether there are any outliers, values far away from the other values, and time, whether there is any change in the characteristics of the data over time. Examining figure 2-2, we see that the histogram is centered around 160. So, tingnan nga natin. So, the histograms shown in figure, ito. Ito, si 2-2. So, ang center niya, around 160 daw. Second or 170 second. The values vary from around 75 second to 325 seconds. Ayan. So, pinaka-center niya around dito daw. Ayan, 160 to 170. Close to here. From 74 to 325. So, analyze natin yung mga nandito. Common distribution shapes. So, ito, na-drawing na natin kanina. Pag medyo magfa-flat siya into a bell curve, then it is a normal distribution. So, nandito yung pinakang gitna, center, nandun sa peak. Tapos, uniform distribution, halos pantay-pantay lang lahat ng bar. Uh, Next, ito, medyo ano na siya, skewed. May kinikilingan na siyang side. So, this is skewed to the right. You have to take note na medyo baligtad to. Baka malito kayo. Kapag ka skewed to the right, ibig sabihin, yung tail niya nasa right, yung longer tail niya nasa right, tapos yung peak niya nasa left. So, pag skewed to the right, the peak is in the left side, and the tail, the longer tail, is on the right side. Ang titingnan nyo yung longer tail. Tapos pag skewed to the left naman, ang longer tail niya nandito sa left side, and then the peak is at the right side. Ay. So, normal distribution. When graphed as a histogram, a normal distribution has a bell curve similar to the one superimposed in figure 2-5. So many statistical method requires that sample data come from a population having a distribution that is approximately a normal distribution. So marami tayong mga statistical tools na pwede mo lang silang gamitin pag normal yung distribution mo. Otherwise, you have to opt with non-parametric statistical treatments. So there are more advanced and less subjective methods for determining whether the distribution is a normal distribution. Normal quantile plots are very helpful for assessing normality. So that is in the part 2 of this section. Later pa daw. Ayan. So this is figure 2-5. Pagka nag-drawing tayo ng bell curve dyan, medyo susunod yung height ng mga bar graphs natin. Now, let's talk about uniform distribution, yung pantay-pantay sa letter B. So, the different possible values occur with approximately the same frequency. So, the heights of the bars in the histogram are approximately uniform. Skewness. Ayan. So, the distribution of data is skewed if it is not symmetric. So, yung isang side, nandun yung peak, tapos sa kabilang side naman, nandun yung longer tail. Also called positively skewed, pag skewed to the right, again, pag skewed to the right, ang longer tail ay nasa kanan at ang peak ay nasa kaliwa. Have a longer right tail. Annual incomes of adult Americans are positively skewed. So data skewed to the left, also called negatively skewed, have a longer left tail. So lifespan data in humans are skewed to the left. Here's a mnemonic for remembering skewness. A distribution skewed to the right resembles the toes of your right foot. So, tingnan nyo lang siya. Pagka skewed to the left, resembles toes on the left foot. Ayan. Di ba kapag longer ang tail sa left, ibig sabihin, skewed to the left yon. Tapos, ang peak ay nasa right. So, ganito siya. Tapos kapag naman skewed to the right, yung matataas na bar ay nasa left side, tapos yung tail, longer tail, ay nasa right. So, tingnan nyo lang yung paa nyo. Tapos, i-compare nyo dun sa data or dun sa graph na presented sa inyo. Pag mukha siyang left na paa, skewed to the left yon. Pag mukha siyang right na paa, skewed to the right yon. Pag mukha siyang pinagsamang dalawang paa, normal distribution yon. Okay? Okay. Now let's go to part 2, assessing normality with normal quantile plots. So some really important methods. Ay, teka. Ano pala? Tapusin natin to. Distributions skewed to the right are more common than those skewed to the left because it's often easier to get exceptionally large values than values that are exceptionally small. With annual income, for example, it's impossible to get values below zero, but there are a few people who earn millions or billions of dollars in a year. Annual incomes, therefore, tend to be skewed to the right. Okay, next. Assessing normality with normal quantile plots. Some really important methods presented in later chapters have a requirement that sample data must be from a population having a normal distribution. Histograms can be helpful in determining whether the normality requirement is satisfied, but they are not very helpful with small data sets. So, criteria for assessing normality with a normal quantile plot. So, sa normal distribution, the population distribution is normal if the pattern of the points in the normal quantile plot is reasonably close to a straight line. And the points do not show some systematic pattern. Pagka not a normal distribution, the population distribution is not normal if the normal quantile plot has either or both of these two conditions. The first condition is the points do not lie reasonably close to a straight line. And two, the points show systematic pattern that is not a straight line pattern. So ito yung isang example ng quantile plot na normal on distribution. The points are reasonably close to a straight line pattern. There is no other systematic pattern that is not a straight line pattern. Pag hindi normal distribution, parang hindi siya magfi-fit sa isang line. Isa pang not a normal distribution. The points show a systematic pattern that is not a straight line pattern. Hindi naman siya straight line.